The next skill we need to master is graphing exponential relationships. So we're going to start the conversation by talking about the domain and the range. The domain is the possible x values. The possible x values for an exponential function are going to be all real numbers. No matter if x is positive, negative, or 0, doesn't matter, you're still going to get an answer. The range, however, is going to have a restriction. There is no value you can plug in for x that will ever make 2 to the x power a negative number. Therefore, your y values are always going to be greater than 0. It's not greater than or equal to 0 because there's no way we can make this value a 0. So all of your values are going to be bigger than 0 here. The first thing you do to make a graph is start with a table of values. I like to use -1, 0, and 1. So to fill in the y values, you're going to plug in -1. So it's going to be 8 times 1/2. Remember, negative exponents mean take the reciprocal. It's going to give us 4. And then 0, we know that's going to be our a value. That's going to be our starting point. Comes from right there. And then I'm going to plug in 1 to get my other point. So the first thing you're going to do is you're going to plot your 3 points. -1, 4, 0, 8, and 1, 16. Once you have your 3 points, you need to make another line on your graph. And what that line is called the asymptote. An asymptote is a line that represents a value that the graph approaches but never crosses. Exponential functions will always be greater than 0. So what we're going to do is we are going to put a dashed line at y equals 0. The reason why we need a dashed line here is because our graph is not allowed to cross y equals 0. It's not allowed to go below y equals 0. So then when you connect your points, you got to make sure that your graph does not cross that dotted line. Okay, we are going to do y equals 27 times 1/3 x raised to the x. Start it the same way. Make a table. Plug in your values. This time I'm going to be dividing by 3 instead. So I know 1 is going to be 9, and then I'm going to plug in -1 means to multiply by the reciprocal. It's going to be 81. I'm going to plot my points. My 81 doesn't quite fit on my graph. Make sure you make your graph big enough. Be around here somewhere. 27 and 9. Put your asymptote at y equals 0. Connect your points. Do not cross the asymptote. We can have 2 different types of exponential relationships. The first one is an exponential growth. The relationship is an exponential growth when it's increasing because the b values are greater than 1. So you can tell if it's increasing if your graph's going up like this. Each of these b values is bigger than 1, So that means you're multiplying by a number that's going to make your values increase. The other type of function we can have is an exponential decay. And what that means is our relationship is decreasing. It's coming down this way because the b value is less than 1. So you're multiplying by a number smaller than 1. So it's going to decrease all of your y values. What happens when a is negative? So first thing we're going to do is we're going to make a table of values and see what happens when our a values are negative. So -4 2 to the negative first power. And remember, negative powers mean to multiply by the reciprocal. So we have -2. My a value is -4. And then when I plug in 1, I'm going to get -8. Okay, so your asymptote is still going to be at 0. And then I'm going to plot all my points. I'm going to change the scale on this graph because I don't need it to go all the way down to 50. I'm going to count by 5s instead. So -2, 0, -4, 1, 8. So then when I connect my points, my graph is going to look like this. We're going to do the same thing for -12 times 1/4 raised to the x. -1, 0, 1. -12 is my a value. I'm dividing by 4, so I'm going to end up with -3 and -48. Asymptote goes in first. And then -1, 48. Zero, -12. 1, -3. So to answer the question, what happens when a is negative? What's happening in our graph is they are reflecting over the x-axis. Next thing we're going to do is we're going to translate these exponential graphs. And what translate means, it's to move or shift the graph. We've done this before with both quadratic relationships and absolute value relationships. Good news here is even though this looks very frightening when you're looking at the equation, the h's and k's do the same thing they always done. K shifts our graph up and down. H shifts it to the left when it's positive, and it shifts it to the right when it's negative. Okay, this one has a little bit of a different procedure, but we're going to start the same way, but we're going to make a table for the parent graph. The parent graph is the function without the h and k values. So I'm not going to worry about this +3 and this +1 just yet. So I'm going to start by plugging in my values. Get 12, 6, and 3. And then the next thing I'm going to do is I'm going to shift all of my points. Since h is positive 3, it's going to move all of my points to the left. So you're going to subtract 3 from all of your x values. Negative 1 minus 3 is 4. 0 minus 3. 1 minus 3. That's how we get our new x values. And then our y values, we're going to do the same thing, but we're going to move them all up 1. 13, 7, 4. Now the question is, where's the asymptote? And the asymptote is going to be at the k value. So our asymptote is going to be at y equals 1. Throw that in there first. Then plot your points. Negative 4, 13. Negative 3, 7. Negative 2, 4. Connect your points just like before. Don't cross your asymptote. Let's do one more. So here we have y equals 5, 3 raised to the x minus 2 minus 8. Started off the same. I know my a value is 5. I know I'm increasing by a multiple of 3. So when I plug in negative 1, I get 5 over 3. So 5 times 3 to the negative 1 is the same thing as 5 times 1/3. That's where I got 5 over 3. And then I'm going to look at my shift, my h and k values. This negative 2 means we're moving everything to the right, 2 values. So I'm going to add 2 to all of my x values. 1, 2, 3. And then the next thing I'm going to do is I'm going to take away 8 from my y values. 7. Negative 3. Need to do a little bit of fraction math here. Negative 19 over 3. First thing that goes on my graph is the asymptote. The asymptote is here at y equals negative 8. Put that on your graph first. The reason why it's at negative 8 is because everything moves down 8. Our asymptote is usually at 0. We shift everything down 8. Now it's at 8. Then we're going to plug our points in. 1, negative 19 over 3. I know you're asking yourself, how in the world do I plot negative 19 over 3? Negative 19 over 3 is about negative 6. It's a little bit more than negative 6. 2, negative 3, and 3, 7. Connect your points. Don't cross your asymptote. And that covers how to graph exponential relationships, how to connect 2 points using exponential relationships, and it describes the pattern of exponential relationships. So remember, if you have an exponential relationship, it means you're multiplying by the same number over and over again. That's your rate of change. And the type of graph we get is a curve.